Hello everyone, I'm He Jiayue. I will introduce cognitive theory of multimedia learning, CTML, and its application in educational video. So let's look at our table of contents first. I will introduce 8 parts of CTML model, learning objectives, answer of CTML model, introduction to CTML model, the key elements, cognitive load theory, 12 multimedia learning principles, educational video, application in educational video, and finally we have a conclusion. So let's look at our first part, learning objectives.
So when we finish our course, we should explain the cognitive theory of multimedia learning and its significance in education, identify the key assumptions and principles of CTML model, understand the relationship between cognitive load theory and multimedia learning, describe the 12 principles of multimedia learning and their relevance in instructional design, evaluate how educational videos can be designed using CTML principles to enhance learning outcomes, apply CTML concepts to create effective and engaging educational videos for different learning contexts. And next, let's look at the second part, answer of CTML model.
Richard Mayer is a renowned educational psychologist who developed the CTML model, contributing significantly to the field of multimedia learning and cognitive science. Mayer's key publications include multimedia learning and numerous research papers that explore the principles of effective multimedia instruction. Mayer is widely recognized in academic circles for his contributions to multimedia learning, earning numerous awards. Mayer's work has profoundly influenced educational psychology by providing a theoretical foundation for designing effective multimedia learning environments. 3. Let's look at Introduction to CTML model. The cognitive theory of multimedia learning is a framework proposed by Richard Mayer that explains how people learn effectively from multimedia materials, such as text, images, animations, and audio. This theory is grounded in cognitive psychology and focuses on how multimedia content can be designed to optimize learning outcomes by considering how the brain processes and organizes information. They assert that people learn more deeply from words and pictures than from words alone, which is referred to as the multimedia principle. And this part, I will introduce influence, 3 cognitive process, principles, and CTML model. The core purpose of CTML is to optimize the design of multimedia materials to convert to the cognitive processing of the human brain, thereby improving the efficiency and effectiveness of learning. Specific influence include the following: 1. Improve learning effect. 2. Reduce cognitive load. 3. Promote active learning. 4. Guide material teaching design. 5. Adapt to deserved learning needs. So, how does multimedia learning works? According to CTML, effective multimedia learning involves 3 cognitive processes. First, selecting. Pay attention to relevant words and images. Second, organizing. Mentally organizing the selected material into coherent verbal and visual model. The third one is integrating. Connecting new information with prior knowledge stored in long-term memory. And here are the 12 principles of multimedia learning, and we will talk about it in the following part. This picture shows how memory works according to Mayer's cognitive theory of multimedia learning. Mayer states that there are also 5 forms of presentation of words and pictures that occur as information is cognitive theory of multimedia learning processed by memory. And each form represents a picture stage of processing in the 3 memory stores model of multimedia learning. And the first form is representation, is the words and picture in the multimedia presentation. The second form is the sounds and images. The third form is the sounds and images in working memory, and the fourth form of presentation is the verbal and pictorial models, which are also found in working memory. The fifth form is peer knowledge or schemas, which are stored in long-term memory. So let's look at the fourth part, the key elements, assumptions. There are 3 core assumptions in CTML model. First, dual channel processing. Second, limited capacity principles. Third, active processing. The dual channel processing explains that the human brain has 2 separate channels to process information, vision channel and auditory channel. The vision channel is the channel process vision input such as images, diagrams, graphs, animations, and written text. Then the auditory channel is the channel process auditory inputs like spoken words, sounds, and so on. The key point is that the 2 channels work independently but can complement each other when used effectively. Using both channels supplementarily can enhance learning because it distributes the cognitive load across the 2 segments. Overloading one channel can reduce learning efficiency. Second, limited capacity. Each channel has a limited capacity for processing information at any given time. This means the brain can only handle a certain amount of information before becoming overwhelmed. The key point is that overloading the brain with too much information causes cognitive overload, making it harder to understand and retain information. Effective multimedia design reduces unnecessary and focuses on essential content to image the learner's cognitive load. The active processing is about learning is not a passive activity. Learners need to actively engage with the material by selecting, organizing, and integrating information. Selecting focuses on relevant images and words. Organizing structuring the selected information into mental models. And integrating, combining new information with peer knowledge stored in long-term memory. And the key point is that multimedia materials should be designed to help learners engage actively with the content, guiding them to focus on key information. Overly complicated or scattered materials can hinder this active engagement. Let's look at the 5-part cognitive load theory. Cognitive load theory was proposed by John Weller in the 1980s to understand and optimize the cognitive load of the brain during learning. It is based on the concept of limited capacity of working memory, emphasizing the cognitive load limits of the brain when processing information. And the working memory is the human brain has a limited working memory capacity and can usually unprocess small amounts of information at once. As a long-term memory is once information has been properly processed, it is stored in long-term memory and becomes part of knowledge and experiences. And there are three factors should be considered when applying principles derived from cognitive load theory: the learner's level of expertise, your content, and, of course, the instructional materials. As part of the analyze phase, you should determine whether your courses include learners with no prior knowledge of the subject matter, with some intermediate knowledge, or perhaps even with advanced expertise. In addition, you should analyze your instructional objectives to determine whether they are simple or complex. The guidelines of cognitive load theory must be based on the complexity of the content and on the experience of the learners. In addition to these factors, one should also consider the media used to deliver the instruction. Two common e-learning delivery media are asynchronous web-based training courses and synchronous virtual classroom sessions. Now I will introduce these three assumptions separately. The first assumption, intrinsic load. It refers to the load that arises due to the complexity of the content itself. Different learning tasks or information have different intrinsic complexities. For example, understanding mathematical questions or physics formulas is often more complex than understanding every language. Another example, when teaching calculus, break down complex divine integrals into simple steps rather than presenting the whole process at once. The next one is external load. The definition is the load caused by instructional design and irrelevant information. Learners may encounter irrelevant distractions or redundant information during the learning process, which consumes unnecessary cognitive resources. And I will give you example. Maybe in an education video, too much animation, too much background music, or unnecessary decorative elements may increase the external load and cause the learner to not understand the core content effectively. The third assumption is germane load. It refers to the meaningful cognitive effort that a learner put into understanding, organizing, and integrating information. It is a load that supports the learning process and promotes deep understanding. Beneficial load is positive in that it helps learners build new cognitive structures or schemes and integrate new information with existing knowledge. Increase beneficial load by designing learning materials that engage learners in active thinking and engagement. For example, interactive questions, mind maps, case studies, and other methods to guide learners to think deeply and actively build knowledge. Then I gave this form about types of cognitive load to help us understand these assumptions more clearly. It's about type, definitions, and example. In order to help learners process information effectively and optimize learning outcomes, we need to manage these three types of cognitive load properly. And here are a key points to help us process information effectively. First, simplify intrinsic load. When designing content, break complex information into smaller, easier to understand parts and present it step by step. For example, start with fundamental concepts before moving on to more complex theories and applications. The second one, reduce external load. Eliminate unnecessary content and version distraction, ensuring that the design is clear and clean. Focus on presenting only the essential information that supports learning objectives. The third one is promote German thought, designing activities that encourage learners to think critically and engage actively with the material. Interactive questions, case studies, and problem-solving tasks can help learners apply what they've learned and integrate new information. Cognitive load theory and multimedia learning. Cognitive load theory provides the foundation for multimedia learning, guiding us on how to design effective multimedia materials that reduce cognitive load and enhance learning outcomes. In multimedia learning, we can use both the vision channel and the auditory channel to present information, which can enhance learning. By carefully combining images, text, audios, and other media elements, we can optimize learning experiences. And cognitive theory of multimedia learning also built on cognitive load theory and offers 12 principles for multimedia learning that help designers manage cognitive load effectively, ensuring the materials are engaging and educational. The sixth part is multimedia learning principles. There are 12 multimedia learning principles. The principle describes that users learn better from words and pictures than words alone. Meanwhile, theoretical rationale for the principle is when words and pictures are both presented, users have an opportunity to construct verbal and pictorial models and to build connections between them. However, when words alone are presented, users have an opportunity to build a verbal mental model, but are less likely to build a pictorial model and make connections between the verbal and pictorial model. The first principle is the coherence principle. People learn better when extraneous material is excluded rather than included. We should avoid unnecessary information, such as irrelevant images, sounds, or text that could distract from the main learning objective. Give you example, in an educational video, avoid adding unnecessary animation or background music that do not support the learning goal. Second, signaling principle. People learn better when cues are added that highlight the organization of the essential material. We can use visual or auditory signals such as arrows, block text, or sound cues to emphasize important information and help learners focus. The example is highlight key terms on the screen during a lecture or use an audio to cue alert learners to important concepts. 3. Redundancy principle. People learn better from graphics and narration than from graphics, narration, and on-screen text, such as avoid presenting the same information in both text and audio formats unless the text provides added value. 4. Spatial contiguity principle. The explanation is people learn better when corresponding words and pictures are presented near each other. Place text or explanatory labels close to the relevant image or diagram. The learners can easily associate them. 5. Temporal contiguity principle. People learn better when corresponding words and pictures are presenting simultaneously rather than successively. The example is that when explaining a complex process, present the text describing each step while simultaneously showing the relevant image or video of the process. 6. Segmenting principle. People know better when information is present in small, manageable chunks. Example is present a video in segments with passes in between so learners can process each chunk of information before moving on. 7. Pre-training principle. People know better when they have prior knowledge of the names and characteristics of the key concepts before learning more complex material. 8. Modality principle. People know better from pictures and spoken words than from pictures and printed words. The example is in a science video, use narration to explain a complex process while showing corresponding diagrams rather than displaying detailed text on screen. 9. Multimodal principle. People know better when information is presented using both visual and auditory channels, as long as both channels do not become overloaded. The example is present a tutorial video with both images of the task and explaining the process step by step. 10. Personalization principle. People know better when the words in a multimedia presentation are conversational rather than formal. Just like instead of saying one must understand the significance of this theory, you can say, let's look at why this theory is important for you to understand. 11. Voice principle. People know better when the narration is spoken in a friendly, human-like voice rather than in a machine-like or monotone voice. If in an educational video, use a pleasant, enthusiastic narrator to engage learners rather than a flat, monotone voice. 12. Image principle. People do not necessarily know better from graphics that are designed to look more interesting or attractive. The example is instead of using complex or flashy animations, use clear diagrams or images that directly support the material being taught. 7. Educational video. At first, I think this part is more easier and interesting to understand. Educational videos are a powerful tool for delivering instructional content in a way that enhances learners' engagement, understanding, and retention. By incorporating both visual and auditory elements, educational videos help the learning process, particularly for complex or abstract topics. And in the context of cognitive theory of multimedia learning, educational videos can be designed to optimize learning by minimizing cognitive overload and maximizing the effectiveness of multimedia content. And in this part, we will learn about importance of educational videos, how to create educational videos, and the types of educational videos. Now let's look at the importance of educational videos. First, multimodal learning. Second, engagement. Third, retention and understanding. Fourth, flexibility and accessibility. Next, we will talk about how to create educational videos. Creating a successful educational videos involves systematic planning and execution from design to release. Here's a step-by-step guide. First step, Define goals and target audience. You should clarify learning objectives, such as a learning objective could be students will understand and apply Newton's third law of motion. Second one, you can design the educational content, prepare the script, create a storyboard, and you can apply CTML principles. Third, gather tools and resources. There are so many software like screen recording tools and animation tools and audio processing tools. And the hardware, you can use camera like a smartphone, digital camera, and microphone and lighting. The step 4 is recording, live shooting. Prepare the space. Choose a clean, quiet environment with minimal background distractions. Framing. Center the subject or use the rule of thirds for balanced composition. Audio quality. Ensure clear sound recording by minimizing background noise. Screen recording. If the video involves software, demonstration, or digital content, use tools like OBS Studio for screen captures. And also you can use the highlights or click sounds to guide the viewer. Next, editing and enhancing the video. You can remove unnecessary parts to keep the video concise. 6. Publishing and promoting the video. There are so many platforms you can select, just like public platforms YouTube, Facebook, knowledge management statement, Moodle, Canvas, professional educational platforms, Google Classroom, and so on. About types of educational videos, I give 5 examples of different types. Educational videos can be categorized based on various learning goals and content needs. Below are some common types. First, explainer videos. Second, tutorial videos. Third, lecture videos. Fourth, demonstration videos. Fifth, animated videos. Educational videos come in a wide variety of formats, each tailored to specific teaching goals and learning needs. By selecting the right type of video based on the learner's characteristics, content, complexity, and objectives, educators can significantly enhance learning outcomes and engagement. 8. Application in educational video. The cognitive theory of multimedia learning provides a solid foundation for designing effective educational videos. And in this chapter, we will learn 5 applications in educational video: segmentation, signaling, weighting, personalization, multiple representation. And I made this form for understanding the 5 applications more clearly. It's about application, definition, goal, and example of these 5 applications. For segmentation, the definition is dividing content into smaller chunks to make it easier to grasp. And the example is divide a video on chemical reactions into sections like reactants and products, writing chemical equations and examples of chemical reactions. The signaling is using visual or auditory cues to guide learners' attention to key information, just like use narrow to marquee parts. The weighting is removing externals or decorative elements that do not contribute to the learning objectives. For example, in a math tutorial video, remove unnecessary background music or complex animations. leaving only key formulas and examples. Personalization, using conventional language, relatable examples, and a humanized design to make learning more engaging and approachable. Multiple representation, presenting information in multiple forms to cater to different learning styles and cognitive needs. Just like in a physics video on machines, use animations to show a car accelerating. And from the research data, this is an example of the application of educational videos in different fields. The first story is about video and psychomotor skills. The second one is health education. Next one is about construction training. And the last story is about police training. At the end of this course, we have our conclusion. The core purpose of CTML is to optimize the design of multimedia materials to conform to the cognitive processing of the human brain, thereby improving the efficiency and effectiveness of learning. And specific influence include the following: improve learning effect, reduce cognitive load, promote active learning, guide multimedia teaching design, adapt to diverse learning needs. Thanks for watching, everyone.